All right, so today we're going to take a look at section 2.4. Okay, so it's on solving linear inequalities. We'll do a little bit on the calculator. Most of it's going to be by hand. Okay, again, if there's anything I go through that you feel you already know, you don't have to write it. Just a reminder, there's 4 different inequality symbols. Derek, what's the first one?
Greater than, or less than, whatever. Less than.
Yeah, it's one of those. Yes, less than. The second one, Skylar?
Less than or equal to.
Less than or equal to. Paragon, the third one?
Greater than.
Yep, greater than. And Sam, the last one?
Greater than or equal to.
Yeah. So we got our 4 inequality symbols. And these are examples of inequalities. The one on the left is just a true statement. 3 is less than 1. The one on the right is a conditional inequality. It could be true if you pick the right values for x. And notice I said values, because with inequalities, there's usually, at least in that problem, there's an infinite amount of answers. Okay? As long as you pick any number that's greater than 4. Anything greater than 4. Okay? So a couple examples. We're going to solve some like this and a little more complicated, but most of that I think you'll have seen before. So how can you tell if a number is a solution? Well, if you plug it in and you get a true statement, then the number you plugged in is a solution. That's how you check it. So like if I wanted to check if, let's say 5 is a solution to this inequality, I plug it in. 3 times 5 greater than 12. Is that true? Yeah, so 5 is a solution. If I wanted to check if 2 is a solution, is 3 times 2 greater than 12? No. So 2 is not a solution. Right? So you plug it in, see if you get a true statement. If it's false, it's not a solution. All right, so conjunctions. Okay, those come up with inequalities, and when you see this word, it's one way to know you have a conjunction. Does anybody know what word we usually have with conjunctions? Usually you have two inequalities, and then there's a word between the two of them. All right, so or could be an option. What's the other word we see? We see and. This is and. So it's 2 inequalities connected with the word and. Sometimes. So you actually can write it without putting the word and. Okay, I'll show you both ways. That's an example of an inequality that's a conjunction. It says x is greater than -1 and x is less than 3. So a lot of times a conjunction is almost like saying between. I have to be between -1 and 3. Now, in this problem, could you include -1 as part of your answer? No. Could you include 3? No. So sometimes when we say between, sometimes we mean just between. Sometimes we also include the endpoint. Depends if it's a greater than or equal to, or less than or equal to. Now, another way to write this is to combine it into one inequality. Does anybody know how you could do that starting with an x in the middle? There's actually 2 ways. Yeah, Chris?
Can't you just write it as -1 is less than x, but x is less than
Yep. So that's one way, and that's the way I actually did it right there. When you combine it, it's almost like the word and is hidden. Okay, you can't, you don't see the word and anymore. But if you read it, that's how you'd pronounce it. X is greater than -1 and x is less than 3. So this part is right there. And this part is right there. Okay, so you should be comfortable with combining them together or splitting them. Let's combine those 2 together a different way. We could put the x in the middle. Or we'll just give it a little break. So yeah, we could put the x in the middle, or Derek, what were you going to say?
So it's going to be 3 is greater than x, less than, or greater than -1.
That's fine too. I usually do it the way that's in black. So I put the smaller number on the left, the bigger number on the right, and both of them point towards the smaller number. Actually, no matter which way you do it, they always point towards the smaller number. Okay. But I just usually do smaller number on the left. So any question about that idea? All right, so now, as I said, this is almost like saying a between. This is an interval. Specifically, this one is an open interval. Open means that you do not include the endpoint. So there's open intervals and there's closed intervals. Closed, you include the endpoint. Open, you do not. Any question on that idea, the difference between open interval, closed interval? It's kind of like open circle, closed circle. If it's an open circle, it means you don't include it. If it's a closed circle, that means you shaded it in and you do include it, like if you were graphing on a number line. So it's kind of the same idea. Now, another word we can use to describe intervals besides open and closed is bounded or also unbounded. Okay. A bounded interval means that you gave me an interval where the endpoints are numbers. There you go. The endpoints are numbers. So here's an example of a bounded interval that's completely closed. Like A and B would be actual numbers. So like if A was 1 and B was 10, that would mean all numbers from 1 to 10, including the 1 and the 10. Now, 1 and 10 are numbers. That's what makes this interval bounded. What could you have in an interval that's not a number? We've had some intervals that have had this symbol in it.
Infinity.
Infinity. Once you throw infinity in an interval, now it's unbounded. Okay? Unbounded because infinity goes on forever. There's no limit. Okay? Bounded means you stop somewhere. Okay. So that's an example of a bounded interval. That's what we call open. It's an open, bounded interval. The endpoints are definite. They are numbers. But you don't include the numbers in your answer. Okay. So I said there's 4 types. What else do you think we could have? We've got a completely closed, a completely open.
Partially open.
Partially open, or partially closed, depending if you're optimistic or pessimistic, but either way. So half open. That's a half open interval, specifically half open on the right. It's closed on the left. And that's another half open interval, this time half open on the left, closed on the right. But they're all bounded. They're all bounded. Okay, so you might hear me throw those terms around when we describe intervals, bounded, unbounded, open, closed. We'll talk more about unbounded in a second. But any questions on the 4 types of bounded intervals? Let's see. Okay, I think page 99, they actually draw pictures for each one. So I'll just do like one picture here. If you wanted to draw a picture for the open interval AB, it would look like this. A, B, open circle, shade between. If you wanted to do the closed interval, you would just shade in each circle. And then for the partially open, you'd shade one of the circles. Right? But they draw it all out for you in the book. Now, what's the other symbol you can use besides an open circle that our book sometimes uses?
Bracket.
Bracket you'd use for the closed.
What's it called?
Think of your order of operations.
Parentheses.
Yeah, there you go. P, PEMDAS. So you can also do a parenthesis, just like that. It's the same thing. And then I was going to mention what you already did, but if you had a bracket, that would represent the closed circle. So, an unbounded interval has either negative infinity or infinity in it. Okay, maybe both. But if it has an infinity, it's unbounded. Those are all examples of unbounded intervals. In fact, that's every type you could have. These are unbounded, the first two here. These are unbounded on the left. One of them is closed on the right, one of them is open on the right. These are unbounded on the right. One is closed on the left, one is open on the left. And I think they draw pictures of those too. I'll do one just to show you. 5 to infinity, that's unbounded. So when I do my shading, it's not going to be between. How am I going to show on a number line using shading that it goes on forever and it doesn't stop?
An arrow.
An arrow, yeah. So like this one would be, let's say 0, 5, bracket on 5, shade to the right. Okay, that's this top one. Top right. So could you have, let's see, an unbounded, fully closed interval? Unbounded and closed. No. Because closed means that it's a number for each endpoint. Unbounded means one of the endpoints is infinity. Those two things are like, it's like saying opposites. You can't have unbounded, fully closed. You can have unbounded, half closed or half open, but not fully closed. So any question on those terms? Okay. So let's see if we can take and translate between interval notation and inequalities. Okay. First of all, can someone just explain to me or describe this interval? What, using the words we just learned, what kind of interval is it? Right? Bounded, yep. And it's a half-closed interval on the right. But yep, definitely bounded. Can somebody write that for me as an inequality? And if we can, I'd like to do it as a single inequality with the x in the middle. Yep, Adrian?
So -3 is less than x, and then x is less than or equal to.
Perfect. That's exactly what that means. X is greater than -3 and less than or equal to 5. Yep, perfect. Any question on that one? All right, how about this one? Peregrine, what kind of interval is that?
Unbounded, half closed.
Yep, it's an unbounded interval, and it's half closed on the left. So Sam, how would you write that as an inequality?
-4
Yep.
is greater than or equal to x.
So just be careful with your sign.
I don't really know, like how do you know which way the sign is facing based on
So think of this like a number line. Like if this is -4, you're basically shading every number from here to the right. That's the answer, if you want to draw it out. So is -4 going to be bigger than all the numbers here? Or is -4 going to be smaller? Then you would put a less than. Or in this case, less than or equal to. Now, do I need to put x is less than infinity? I mean, I see a lot of people, they do this. And I'm just, yeah, everything's less than infinity. So you don't have to write x is less than infinity. Because it doesn't really tell me anything. All you have to say is this. If you wanted to write it with x on the left, you could do that. But I would take that, but it's fine. Any question on this one? Okay, let's try this one. So Chris, what kind of integral do we have there?
So that is a bound closed.
Yep. Now, if he had to pick just one of those words to say, he said bounded and closed, which word could he just say and it would automatically imply the other one?
Fully closed.
Yeah. If you say it's fully closed, then let's see, was that actually true?
Yeah,
Yeah.
because
Because
an
Yeah.
unbound can't be fully closed.
Yeah. Because if it's fully closed, you can't have an infinity, so it would automatically imply bounded. But you can say both too. That's fine. So now let's write that as an inequality. How about Vinny? Could you tell me how to write that one?
Alright, -8
Yep.
is less than or equal to x.
Yep.
And it is less than and or greater to -3.
Can you say that last part again?
Sorry. Less than or equal to -3.
There we go. So it's basically all x's between -8 and -3, including -8 and -3. Okay. So any questions on that one? So if on a test or homework they ask you to describe the interval that's a solution, you can do interval notation, or you can do it as an inequality. If they don't say which way, pick whatever makes you happy. Okay, so this one they want me to solve it, but I have to graph it. Now there's not too much work to solve it, because x is already by itself. So we just graph it. So I have a number line? No. Alright, so let's put a number line on there. Okay. When you have to make a number line, just you can number however you want. You can go by ones or two, whatever you need to. I'm just going to go by ones. I think that's simple enough. All right. So Piper, how would I graph that?
You could do a closed bracket at the 2. And then,
Yep. Bracket.
And then shade to the right.
Yeah, and shade to the right. If she didn't say bracket, you still have to shade to the right, but what other symbol could she have used if we did it that way? Yeah.
Closed circle.
We could have used the closed circle, which I thought you were going to say at first when you started with closed. But yeah, we went with bracket.
So are they interchangeable?
Yeah, I wouldn't mix them in the same problem though. Stick with the same, either stick with brackets and parentheses in the same problem, or circles. Yep. Yeah, just don't mix them in the same problem. Okay, x is less than 5. Let's do that one. Let's just go -5, 0, 5. Good enough. Maddie, how am I going to graph that one?
You would do an open circle on 5
Okay.
and then shade to the left.
Yep. So open circle on 5, shade left. Perfect. And let's do this one. So this is one where when Adriana asked me, can you interchange them? Yes, but here you're going to need 2 symbols. Stick with the same circles or brackets and parentheses. So how about Zach? Can you tell me how to graph this one?
Yeah. So on -1 is going to be a closed circle,
Okay.
and then on 3 is going to be an open circle.
Yep.
And you just shade in between.
Shade in between. And what's this one called again? This type of inequality?
Bounded, right?
It is bounded.
Oh.
It's half open.
Yeah, it's
There's a lot of
less
ways to
than or
describe
equal
uh,
to the one -1 and x that's less than or equal to.
So I'm thinking of something else. I'm thinking of, because there's like a special word, if you were to pronounce that, you would have to say. It's a conjunction. Yeah. Yeah, so this is a conjunction, but everything else you said, bounded and all that, that's also true. So now we're going to look at some problems we actually have to solve. Okay, the only difference between solving an inequality and an equation is if you multiply or divide both sides by a negative, you have to flip the inequality. It's not like something will automatically alert you to that. You have to remember to do it. Okay, it's not like you'll get an error on the calculator or something if you forget. It'll just do it the way you do it. So just remember to flip it if you multiply or divide by a negative. Alright, so let's take a look at this one. So we got 3, and then in parentheses, x minus 1, close parentheses, plus 2, is less than or equal to 5x plus 6. Pat, what would be my first step to solve that?
You'd want to distribute the 3.
Yep. And if I do that, what do you get?
3x minus 3.
Yep, and you know what? Let's do something else at the same time. You said 3x minus 3. Let's do the plus 2.
So it come back to 3x minus 1.
Yep. Okay, so we distributed combined like terms. J-Lise, what would be the next thing I could do here?
Honestly, I'm not.
You're not sure? Well, you have a couple options. Eventually, we want all the variables to be where?
On one side.
On one side, right? So we could either take the 3x and put it over on the right, or the 5x and put it on the left.
So you put the 3x on the other side.
Yes, and how would you move it to the other side? Subtract it. So minus the 3x gives me negative 1 is less than or equal to 2x plus 6. What about my next step? Now I don't have any more choices. I pretty much have to do something. Derek?
Subtract 6 from both sides.
Yep. And what's negative 1 minus 6?
Negative 7.
Good. And my last step? Divide by 2. So x is greater than or equal to negative 7/2 or negative 3.5. The decimal would be handy if they want you to graph it. But, nope, they just said solve. Now, how come I didn't flip the inequality? I divided both sides by 2 and I had a negative right here. Right, the 2 wasn't a negative. It doesn't matter if there's a negative on the other side. It's, did you divide by a negative? And the answer is no. We divided by positive 2.
So you would flip it if it was negative?
Yep, if the problem, I'm not gonna change everything up. But if you get to this step and you had a negative right there, divide by negative 2, well, first of all, that negative would cancel, and that would point the other way. Yep. Anytime you multiply or divide, too much. You gonna ask something?
Yeah, is it okay if you just put the x on the other side?
Yeah, I like it better that way. It's because now if I'm going to graph it, it tells me to shade to the right. This is kind of weird to write, but it wouldn't be wrong. This is, yeah. Okay. Any questions on that one? Okay, so I know I'm going through it kind of quick, but again, I'm thinking most people have seen that stuff way back in Algebra 1 and Algebra 2. Probably not in geometry as much, but. Okay, so solving an inequality with a graphing calculator. There's 2 ways to do it. We'll try both. So one method is almost like you're solving a quadratic. Get 0 on one side. Okay, so you get 0 on one side, and then you're going to do second, calculate root. Once you know the root, the answer is going to depend on if the original problem had a less than or greater than. So we got to do a problem to see it. But the answer is either going to be where you were less than your root or where you were greater than or equal to. Right? So it depends on the problem. All right. So calculate root. You might have to also calculate roots, plural. I don't think you're gonna have to do plural today, because we're dealing with linear inequalities. And linear inequalities only cross the x-axis once. If you had like a parabola, okay, something like this, and I said to you, where is that parabola less than 0? The answer would be between here and here. So you have to find those two roots. And that's where it's less than 0. But with lines, I don't think we're going to have to worry about more than one root. So. Okay, so let's try this one. 4x minus 1 is less than 2. So, to do method 1, what's the first thing I would have to do in this problem? Get 0 on one side. This is how I would do it. So we're going to graph the line 4x minus 3, and we're going to look for where it's less than 0. Okay. Where is it below the x-axis? All right, so let's graph it. Zoom. Still running off 2.0. I could upgrade to 3.0 or something. All right, so it's 4x minus 3 is less than 0. 4x minus 3. You don't have to worry about the less than 0 part. That's, you don't have to graph anything else. Okay, let's do zoom 6. Okay, so now we're going to do second calc. On my calculator, it actually says root. We're calculating the root. That means calculate the 0. Option 2. Pick a point that you know is to the left of where it crosses, the right, and hit enter. So the root is at 0.75. So now, we want our inequality to always come out less than 0. So what I want to pick values greater than 0.75, which would put me up in the top part, or less than 0.75. Less. So that's the answer. There's a picture too. So x is less than 0.75. Okay. So anything less than 0.75 is going to bring you to the left, which is going to put you below the x-axis.
So what were we just trying to find there? Like what was?
We just solved this inequality by calculating the root.
Oh, okay.
Yeah. So if you plug in any number that's smaller than 3/4 for x, you'll always get an answer that's smaller than 2.
Oh.
I mean, we could have probably solved this one just as fast by hand, by adding +1 and gotten 3, and then dividing 3 by 4.
Right.
Now, method 2, for solving the inequality, you don't have to rearrange anything first. You just leave it the way it is. Put what's on one side in y1, put what's on the other side in y2. And in this case, you're looking for where the graph in y1 is less than the graph in y2. Less than means under. Where is it underneath it? So this time I'm not going to calculate a root. I've got two different graphs on the screen, and I'm going to see where these two graphs do what? Where they intersect. And the answer is either going to be everything less than the intersection or everything more. Okay, let's see what happens. That's what I just said. Determine if you want the x's below the intersect value or above. Okay, so let's type in 4x minus 1. That was the original side, left side. We're going to put 2. So it's like there's this extra step because we didn't get it equal to 0. Okay, or we didn't get 0 on one side. So now we've got 2. I'm going to hit graph. And if you want to think of it in terms of the color, we're looking for where the graph in blue is under the graph in red. This one I drew in blue. This one I drew in red. Okay, so how do I get to intersect? Where is that?
Second calc.
Alright, so second calc, intersect, blue, red, enter, and it says they intersect at 0.75. So this is actually example 5. We already did it. Right there. Now, we're looking for where the graph in blue is under the graph in red, where it's less. Is the graph in blue less when you go to the left or when you go to the right? To the left. The graph in blue is underneath. So x is less than 0.75. So it's two different ways to get the answer on your calculator. Any question on either method?
So if the obstacle is above, then it'd be greater than?
Yeah, if this was the problem. Now you're asking me if you want to look at it in terms of the color. Where is the graph in blue above the graph that's in red? So where is the one in blue above it? If you go to the right of that intersection point. And with lines, you don't really need to worry about, like, well, it's above it here, but then it goes back below it, and then it goes back above it. Lines don't curve like that. When we get into ones that curve, like if you had something like this, and I said, where is the graph in black above the graph in red? Well, there's a couple spots. From here to here, the graph in black is above the graph in red, so I would need to know these 2 points. And then from here, assuming that just goes on that way forever, I would say that point forever on. Okay? But we're not really looking at ones that curve yet. But we will. Okay, so this is kind of like a compound inequality, but the x isn't by itself in the middle. To solve it, basically it's like solving an equation, but whatever you do to the middle, you have to do it in 3 spots. Middle, left, right. So you think of an equation, you got to do it on the left, you do it on the right. Think of this as having 3 spots. Do it in all 3. Same rules apply if you multiply or divide by a negative. Still going to flip inequalities. Alright, so I'm not actually going to solve that one. I'm going to do a little different one. But let's look at this one. So it says negative 3 is less than 2x plus 5 divided by 3. That's all in the middle. Less than or equal to 5. Okay, so my goal is to get that by itself. What's the first thing you would do? Yep, multiply everything by 3. There, you just cancel them. What's negative 3 times 3? Negative 9. Less than 2x plus 5. And 5 times 3? How come I didn't have to flip anything? I didn't multiply by a negative. Okay, what's my next step? Subtract 5. So we're going to have 2x. What's negative 9 minus 5?
Negative 14.
Negative 14. 10. And now my last step. Divide by 2. Divide by 2, 2, 2. Just have to do it everywhere. And if that 2 was a negative, I would have flipped it. But it's not.
Would you have flipped both of them?
Yep, you always flip both. Yep. So that's gone. Negative 14 divided by 2 is negative 7. And if you write your x, that's always good. So negative 7 is less than x, which is less than or equal to 5. Any questions on that one? So that's solving a compound inequality. All right, let's try this one. So it's a rectangle problem. It's really just another variation of like the same kind of thing we've done with perimeters and areas, or like the length is twice the width, stuff like that. So it says we've got a set of rectangles where the length is one more than twice the width. How could you write that?
2w plus 1.
Yep. I don't know if we're going to need that, but I don't know. They said all that stuff in words, so we might at one point. The length is one more than twice the width. Find an algebraic representation of the rectangles that have perimeters of less than 100. We did this exact same thing in the homework. I think it's at 360. I think you had mentioned I had messed something up and you helped me with it. So the only difference with it is it's going to not have an equal sign. It's going to have a less than or a greater than. So what's my, let's just start with the formula for perimeter. Perimeter equals, what is it for rectangle? Yep, 2L plus 2W. And they want, let's see, an algebraic representation where the perimeter is less than 100. All right, so here's my perimeter. So I want 2L plus 2W to come out less than 100. But what can I plug in for L? Yeah, plug it in just like that. So when you plug in L, you have to double it. So what does that turn into? 4W plus 2 plus 2W. And combine like terms, what's 4W and 2W? Yep. So 6W plus 2 is less than 100. So there's an inequality that represents what they said to do. Now, let's take the inequality and find the possible widths of my rectangles. So basically, just solve it. First step to solve it, subtract 2. What's that, 98? And last step, divide by 6. So that tells me if I want the perimeter less than 100, and I want it to meet this condition where the length is one more than double the width, my width has to be less than 16.3. 16.3 repeating. Now, it's said to find the possible widths. There's a little more you have to say here. I can think of a width that's less than that number that wouldn't work.
Negative.
Yeah, you can't have negatives. So you have to add that little piece in. The width has to be greater than 0, but less than 16.3. Okay, any question on that? All right. So I think this is the last thing, absolute value inequalities. Yep. So we'll take a look at how to do this. So kind of like solving absolute value equations, like we did yesterday. You got to make sure the absolute value expression is by itself. And then you split it into 2 problems. The first problem is the same as the original. You just take away the bars. It's exactly what we did yesterday. Now, for the second problem, what's the extra thing we had to do yesterday? Yeah, we made the number on the other side the opposite. Now, you're still going to do that. Second inequality is the same as the original. You're going to change the sign of the number on the other side, but that's the new step. Your other inequality has the sign flipped. Okay, so the second inequality that you get from an absolute value, take the bars out, make the number negative, just like with an equation, but also flip the sign.
So make the number on the right negative?
If it changed the sign of it. So if it was positive, you'd make it negative. If it was negative, you'd make it positive. Yep, there'll just be a number by itself on the right. Kind of like, well, I'll show you an example in a second. Now, once we solve it, we have to decide on the final answer. You're going to get 2 things. Like yesterday, we may have had x equals 2, x equals 6. Well, For this one, you're gonna get two answers. But we have to decide if the two answers should have the word and or the word or between them. Okay, so this sign flipping thing and this step right here is new. If the original problem had a less than or a less than or equal to, that's an and. You don't have to worry about the symbol intersect. We've used this or one a lot, union, but we're going to stick with the words and or for this. So if you had, and this is how I remember it, if you had a less than, you use an and. Land. Less thans, use and. Greater thans, use or. Gore. Land. I just remember land. Less than is and. Okay. Greater thans are or. All right, so let's try this one. So before I even start it, okay, I want to check if the absolute value is by itself. Is it by itself? Yeah, then we're fine. We're fine to split it. Sometimes what I do is I write down right now if it's and or, so I don't forget. What's the inequality in this one? It's a less than. Land. Right? And. So put the word and so you don't forget that. What's my first inequality? Yep. What else? Is less than 3. And what's my second inequality?
X minus 3 is greater than
X minus 3 greater than negative 3.
Yes, x minus 3 greater than negative 3.
Oh, I get it. Where did you get the negative 3?
So this one you do 3 things. Take out the bars, flip the sign, change that to a negative. That's where the negative comes from. You have to change the sign of this number. Now, if that number already was a negative, I would have made it a positive when I switched the sign. So now we solve it. X is less than 6, and x is greater than 0. That's it. That's how you solve an absolute value inequality. It's very similar to an equation with a couple little extra steps. Questions on that? Now, what did you have to be careful about with that number when we were solving equations? Had to be greater than or equal to 0. This doesn't. That number can be anything. Positive 3, negative 3, doesn't matter. Because it's an inequality. So it's okay if it's a negative number.
Can't that not be a negative number? Absolutely.
Let's see. Actually, yeah, I take that back. No, it's the same. Yeah, you have to be careful. It's the same thing. If you take the absolute value of something, it's always going to come out positive. So it can't be less than, yeah, it still couldn't be. So it's this, actually, it's the exact same restriction we had yesterday. Sorry, scratch the first thing I said. Yeah.
And if it is like 0 or less than 0, it just doesn't work, right? There's just no answer.
0 is okay. If it's less than 0, then you'd have to say no solution. Yeah. But 0, you could solve it with 0. It'd be a little weird. You'd only get, well, I'm not going to give you one where it's 0. It would be more like this. Actually, I should be careful. If this was 0, could you solve that problem?
Yeah.
Does the absolute value ever come out less than 0? No. How about less than or equal to 0?
Yes.
Yeah, that you could do. And x would be 3. That's basically the only answer to that problem. 3. And it's equal. Right? But that's kind of the standard normal case, nothing special. Yeah.
So Should your final answer be solved?
Should your final answer be
Like,
solved?
yeah, like, you know, how you like simplify it on there.
That's as simplified as I can do. You should always
Right,
do what's circled.
so should we have it like that, you know? Like, you know how it was x minus 3 is less than 3 at first?
Yeah, this is not done here.
Okay, so you, yeah,
Yeah, because this doesn't still tell me what x is yet.
right,
Yeah, so always write it the way I circled, yep.
okay.
And technically I could have circled the word and. I mean, that whole thing is the solution.
Because you need and, right?
Yes, you gotta have and. If you forget the word and, I'd probably take a point off. Because there's a difference, big difference between and or.
But what if you had in the whole you take out and put the two.
You could do that too, yep. This implies and automatically. This is perfectly correct as well. Yep.
But you could do that for or.
You can't do that for or. No, there's no way to take an or and combine it. Only an and.
So you don't use union anymore?
No, I don't. We're gonna stick with the word and or for this. Union and intersect are usually used with interval notation. It's kind of like it's a different thing, so we're gonna stick with and or for inequality notation. Yeah. If you were doing this as intervals, you'd have something like x is less than 6 would be this. That's x is less than 6. Intersected with x is greater than 0. That's exactly the same answer. But we're sticking with and or.
Yeah, that's good.
This means and. When you do interval notation.
I think I did a little bit of that in freshman year.
Yeah, you can. We're just not gonna do it. We've done the union symbol when we do some intervals, but for this stuff, I just want you to stick with and or. Yeah. All right. So this one is kind of it's like a setup they give you where they say something like x is less than 3 units from 10. Set up an inequality for that. This is the template that you use. If you want to set up an inequality that represents that situation, like x is 5 units or less than 5 units from 6. That's the inequality. And what that basically means is this. If x is less than 5 units from 6, that means you're up here. And I can't talk right. You're up here and down there. That would be the range of numbers that are less than 5 units from the number 6. That's what that means. And this inequality would solve that. That would be an and. And it would, if you solved what I just said, x is less than 5 units from the number 6, you would get x is greater than 1 and x is less than 11. And you'd shade between. Okay, so let's try this one. So it says x is within 4 units of the origin. So the origin is what number? 0. Okay. So just as a reminder, let's see. This b is what you are away from. That's like your center. Okay. So x is less than. This is what you are. I don't want to say away from. It's kind of what. It's like the center. I don't know a better way to say it. And A is how many units away from that center you're going.
So we got the starting point, which is B, and then A is how far?
Yeah, it's the units away from the center. So units away from center. So I can figure this out quickly in my head. If I'm within 4 units of the origin, I'm between -4 and 4. So we know what the answer should be. Let's set up this inequality and see if we get -4 to 4. Okay? So absolute value of x minus, what's kind of my center? What am I measuring away from? 0. And how many units am I away from that? 4. So if you solve this problem, you basically have this. That's an and. Less than is an and. And you would have x is less than 4, and x is greater than minus 4, which is exactly what we said just by thinking about it, between negative 4 and 4. Okay? So that's all that this inequality does, is it sets up a formula for being away a certain amount of units. How about this one? X is less than 3 units from 2. So what's my center? What am I away from? We're measuring from 2, and I want to be within how many units? 3. So if you solve that, you should get an answer between negative 1 and 5. That's within 3 units of the number 2. Now, what if they said x is more than 3 units from 2? What's the one thing that would change? The sign. It'd be a greater than. It'd be a greater than, and then it would be an or. Either you're greater than 5 or less than negative 1. And that would put you more than 3 units away from 2. Okay. Any question on that? Alright, let me see. So the last thing is on the calculator. So this was an or. I think I'm going to skip going through that. Because you'd solve it just like we solved an and. 3x minus 2 is greater than 1. Or 3x minus 2 is less than negative 1. You guys should be able to handle that. Alright, so let's finish up with this one. So I was going to do it on the calculator, but let's try it algebraically. They want to know when that fraction is going to be greater than 0. So think about that a little bit. When is this going to be greater than 0?
It's greater than 2. If x is greater than 2.
If x is good. So if I plug in like negative 10 here, the bottom wouldn't come out greater than 0? What's negative 10 minus 2?
It's the, okay, I got you, yeah.
Negative 12. And what's the absolute value of negative 12? 12.
So anything except for 2.
Yeah, except for 2, because 2 would cause a divide by 0. That's a problem. So we never really have to worry about the bottom. Okay. The only thing, keep this in mind, x can't be 2. But the bottom is always going to be greater than 0. So to answer this question, all we have to know is when what?
The top.
When the top is greater than 0. As long as the top is greater than 0, you're guaranteed the bottom is greater than 0. And if you divide a greater than 0 by greater than 0, you will get a number that's greater than 0. So when is the top greater than 0? When x is what?
Greater than negative 3.
Greater than negative 3. And what? And not equal to 2. Because if your 2 isn't, that's another problem. So x has to be greater than 3, but not the number 2. And that's it. So there's really no algebraic, I guess just one step, minus 3 from each side. So that was pretty much everything that we're going to do with linear inequalities. I think tomorrow we'll look at inequalities that are not linear. And that'll finish up chapter 2. All right, so on, those are even and even. All right, so the homework, it's 5 through 7. And then everywhere else there's a range, it's just the evens. So 10, 11, 14 to 16 is just, I guess I could have just done 14 comma 16. Probably would be simpler. 14, 16. 19, 20, 22. 24 and 26, just the evens, 24, 26. And then 29, 34 to 38, just the evens, 42, 43, 49. And 60 to 62, just the evens there. So we'll take a look at that tomorrow, and we will finish up chapter 2.